Hello everyone. Topic in this video is process control block. Okay. So first of all, let's see the definition of PCB. It is a data structure maintained by operating system for every processes. Now, what is process? What are the state of the process that we have seen? Okay. And if every single program when it is executed by CPU, it is known as a process. Now it is not compulsory, it is not compulsorily possible that CPU complete this process in a single attempt. Okay, there can be a process switching, because in multi-programming many processes are executed by the CPU. So the question is, how this operating system maintain which process is in which state, how many child processes created by that particular processes, what is how to recognize that particular process in entire operating system. Okay, so these are the various, it required some kind of a track. Okay, so that operating system can do its task, or it can do this process execution smoothly. So for that purpose, this PCB is it is implemented, and which is maintained by operating system for each and every process. It is used for storing the collection of information about the process. For example, what is process ID? This particular process is in which state? Okay, like that. PCB is identified by an integer process ID. For example, let's say over here there is one process. Okay, I am executing one simple C program. Okay, and if I am executing it, that means at that time it is known as a process. So operating system, it create one data structure related to this particular process, which is uniquely identified by its integer process ID. Let's say 1 2 3. Okay, which is unique in entire operating system. PCB keeps all the information needed to keep track of the process in that particular data structure. PCB is maintained for process throughout its lifetime, and it is deleted once the process terminates. So once I executed my C program successfully and I terminate all the things. Okay, so that particular PCB that was created to execute this particular program, it is deleted once my program execution is completed. But if it's not compiled successfully, or something went wrong and I need to change it later on, then it will be kept as it is. Okay, once I finish the program, then only it will be terminated. Termination, it will be from OS side. Okay, externally we don't have to do anything. The architecture of a PCB is completely dependent on operating system, and may contain different information in different operating system. Just we have there is one point that it is used for storing collection of information about the process. So does this means all the operating systems store all kind of information? No, it's depend on operating system. Okay, so okay, there is one point, PCB lies in kernel memory space. Okay, which is very important topic. You should remember this, because okay, there are certain situations, for example, whenever this process is communicating, or whenever process switch occur, then the control is user have to switch on kernel side. Okay, and maybe it may be possible that we need this information related to particular process. That's why it is in kernel memory space. Okay, and obviously various information is kept in this data structure, and it should be secure. So that's why it is placed in kernel memory space. Now let's see what are the parameters that is stored in PCB. So first one is process ID, unique identification for each of the process in the operating system. After that, process state, the current state of the process. For example, whether it is in ready state, or running state, or waiting, or a block state. Okay, so if it is in running state and some other higher priority process arrive and get execution, then this process, it will be in is process which will be occurred, and process state, it will be updated like ready in PCB. Pointer to a parent process. Okay, after that, priority. Now it is there are various scheduling algorithm which are this priority is considered when we talk about scheduling of this process, scheduling algorithm. Okay, so for example, there are certain processes which are of low priority. There are certain other processes which are of high priority. That means they should get executed first. Okay, program counter, it is a pointer to the address of the next instruction to be executed for this particular process. After that, CPU register, various CPU registers where process needs to store for execution of a running state. For example, if I am executing one C program, okay, and it has performed a certain calculation, and this result of this calculation needs to be stored somewhere. So it may be possible it is stored in these registers. Okay, so this registers are also needs to be tracked in this PCB data structure. IO status information, which includes the list of IO devices allocated to the process. Accounting information, this includes the amount of CPU used for process execution, time limits, and etc. For example, there are certain time limits. Okay, and this accounting information, for example, for how many cycles CPU is allocated to that particular process. So these are the accounting information, and which may be used in to understand certain analysis or that kind of, okay, to understand the performance of any scenario or a situation. Now IO stated information. Now for example, a particular process needs to read data of certain file. Okay, that means you have to open that process needs to open that file. It requires access to that file. Okay, so this information is also needs to be stored somewhere in this somewhere. So PCB maintain track of all this information. Okay, and for every process there is unique PCB. Okay, so this is all about PCB.